Okay, in this video, I'm going to take a look at the integral of x square root of 5x plus 1 dx, and we're going to use integration by parts, spoiler alert. So what initially, so let's pretend like I didn't prompt this with integration by parts. Let's just set evaluate. What you would initially probably think is substitution. Like you would want to set some u equal to probably 5x plus 1, and then you take du equal to derivative of 5x plus 1 is 5 dx. Doesn't work. Doesn't work. So that's why we're using integration by parts here. Because the substitution does not substitute out because we have that x. We have x there. So that's a problem. Okay. So we're going to use integration by parts. So integration by parts, we want to set a u. So I'm going to set u equal to x. And then that means my dv is going to be 5x plus 1 to the 1/2 dx. So remember, with integration by parts, our u, we're going to take the derivative, and then our dv, we're going to take the integral. dv to v is going to be the integral of that. So the derivative of u is going to be du, that's going to be 1 dx. And then the integral of dv, so this is where this problem gets a little bit messy, and not just in this spot right here, but there's going to be quite a few integrals that we're going to be taking. So I'm going to do this off to the side. So I'm going to take the integral of 5x plus 1 to the 1/2 dx. And you can do this however you want. Like some textbooks might just use different lettering since we've already called u, or they might use w's. It doesn't really matter. It's just whatever makes sense to you that you want to go ahead and integrate this. And maybe you're at the point where you're pretty comfortable with just doing this more mental than anything. But if not, that's completely fine because this is tough. This is a tough integration to do. So I'm gonna set my u equal to 5x plus 1. So then du is equal to 5 dx. So now notice that I have dx. I don't have a 5, so I just have to offset that by dividing by 5 here. So I'm going to have 1/5 integral of u to the 1/2 du. So I replace 5x plus 1 with u. And that was to the 1/2, and I set u equal to 5x plus 1. So right now what I'm doing, again, this is just this. I am just trying to get from dv to v right now. That's all I'm doing. I'm not even doing integration by parts. I'm just trying to deal with that. Okay. So then now I'm going to integrate that. So that's going to be plus 1. That's over 2. That becomes 2. 2 plus 1 is 3. That's going to be divided by 3/2, which is 2/3. So I'm just going to write that as 2/3. So I get 1/5. 1/5 times 2/3 u to the 3/2. So let's now take that as 2, and then u is equal to 5x plus 1. That's what we said our original u right here, 5x plus 1. So 5x plus 1 to the 3/2 over 15. 5 times 3 is 15. I replace u with 5x plus 1. So I think we're good now. I think we now have done dv to v. After all of that, that's all of that work right here. This was all just trying to get from dv to v. So dv to v was 2 over 15, 5x plus 1 raised to the 3/2. So that is our v. Now, to actually do the integration by parts portion of this, the uv and so on. So u is x times v, which is that whole complicated statement that we just came up with, 2 over 15 times 5x plus 1 to the 3/2 minus the integral of v du. So this is v du And luckily du is just dx, so that's kind of nice. So v is 2 over 15, 5x plus 1 to the 3/2 dx. Not out of the woods yet, because now we have to integrate this, which, again, if you're getting pretty good with substitution, it's the exact same exercise as we did over here. It's the exact same thing, just with this 2 over 15, but we could just ignore that 2 over 15, and then you could redo the process if you want. But all that ends up happening is just the u is going to be a little bit, it's going to be u to the 3/2 rather than u to the 1/2 this time, so you can't just like completely recycle because we have that to the 3/2, but not a big deal. It doesn't, I don't think it increases the level of difficulty really. It just, you got to be a little bit more careful. So let's go ahead and take care of that then. So this is just going to come over here. I'll ignore that for a second. I don't really need that. I do need to take care of this integral though. So I'm going to integrate this. I'm going to take out the 2/15. I'm going to call 5x plus 1 u. So u equals 5x plus 1. So it's going to be du equals 5 dx. So again, we're dividing by 5. Same thing that happened before. So du over 5 is equal to dx. So I'm going to take out a 5 along with that. So I'm going to have... trying to decide how to make this the most clear as I can. So here's what I'm going to do. I'm going to change this to 2 over 15, then the integral of 5x plus 1 to the 3/2 like that. And then I'm dealing with this right here, and then I'll deal with that 2/15 at the end, just to make this a little bit easier. So it's going to be 1/5 integral of u to the 3/2 du. So it's 2 over 15, I'll just multiply at the end. So now we integrate u to the 3/2. That's going to be plus 1. So plus 1 is making that denominator 2. That's going to be divided by 5/2, which is the same thing as 2/5. So I'm going to have 1/5 times 2/5 u to the 5/2. Couple things that need to be multiplied here. We're going to have 2 over 25. I'm going to take out the u, replace it back with 5x plus 1. So that's going to be 5x plus 1 raised to the 5/2. Okay, so now what I just did is this. So right here, I took this out. That was 2 over 15. And then I integrated this in blue brackets off to the side here. That is all this mess. So I had u equal 5x plus 1. We had that 5. I had to take out a 1/5. I integrated u to the 3/2. That became u to the 5/2 over 5/2, which is the same thing as 2/5. U to the 5/2. Take out u. Then multiply that 1/5 by the 2/5. So now this still needs to be multiplied by this. So this is going to be minus 2 over 15. And then I have this that still needs to come along for the ride. So this is going to be 2x over 15, 5x plus 1 to the 3/2. And then I'll go ahead and write all this down one last time. So 2x over 15, 5x plus 1 to the 3/2 minus 2 times 2 is 4. 15 times 25, got to double check, 375, yep. 5x plus 1 to the 5/2. Wow. So first off, wow. This problem is a very overwhelming problem, but I don't think that it's a difficult problem if you know what to do. Like if you know how to substitute, if you know how to integrate with substitution, like right here, then you're just doing that multiple times while trying to keep track of all these constants. So I don't think the level of difficulty is any higher than any other problem. I think there's just a lot messier and there's a lot more room for potential mistakes. So you really have to be careful as you're going down the stretch, like this back half here, making sure you're careful with these constants. Like right here, like just this step right here, this is how I took out that 2/15, and then I essentially just ignored it until I got down to the end. Now, you could have just said, like, all right, well, if we have 2/15, you're taking out 1/5 because of this step right here. You could have multiplied 2/15 times 1/5 there, and then multiply it again by 2/25. It doesn't matter, or the 2/5, excuse me. It doesn't matter how you go about dealing with that. For me, just the visual, like, I just would deal with this constant after, and then I'll just go from there. But it's completely up to you how you want to go about doing that. And I'm going to leave the answer as this. Then that's probably a win for now. And just leave it at that, because that's a good problem. It's a tough problem.